Welcome to our nocturnal laboratory of gentle discoveries. Here at Dreamtime Science, we transform complex concepts into lullabies for the curious mind. You know, I've been thinking about how many moons there are swirling around the planets in our solar system. It's like each one tells its own quiet story. There's something remarkable about how these little worlds, from tiny rocks to icy giants, have their own unique personalities and secrets. Tonight, I'm excited to share some of those stories with you, and maybe we'll discover together why these moons feel like tiny companions in the vastness of space. If these gentle explorations bring you comfort, a quiet like or subscription would mean the world to me. Your support helps keep these peaceful journeys flowing. Now, take a moment. Adjust your blanket. Find the perfect hollow in your pillow. Let your shoulders melt. Breathe in and out. When darkness falls across the turning face of earth and the horizon softens into a velvet hush, a pale sentinel rises above rooftops and rolling hills alike. The moon, our steadfast companion, drifts quietly across the sky, its silver gaze both intimate and remote. But what if you looked further, beyond the reach of our own moon's mellow glow? What if you cast your imagination outward, far beyond Earth's embrace, to wander the grand ballrooms of the solar system, where dozens upon dozens of other moons, each strange, each singular, glide in their own celestial dance? Consider this. Our solar system is not merely a family of planets orbiting the Sun, but a vast whirling waltz of worlds and their retinues, planets accompanied by a host of moons, each one a story, a secret, a stage for cosmic drama. These moons are more than mere satellites. They are ornaments of the night, witnesses to the slow unfolding of cosmic time. Their presence stirs something deep within us, a sense of kinship and wonder that echoes through the bones of our ancestors. From the earliest flickers of human thought, the moon has been more than a lump of rock. It has been a mirror for longing, a calendar for planting and harvest, a lantern for lovers and a harbinger for poets. Its phases have marked the rhythms of life, tides waxing and waning, months measured out in silver crescents, stories woven into its shifting face. In every language, in every culture, the moon has inspired tales of gods and monsters, of lovers and dreamers, of madness and mystery. But Earth is not the only world with a moon to call its own. Each planet has its companions, and each companion carries its own tale, woven into the mythologies both ancient and modern, scientific and speculative. Let your mind drift outward now, past the familiar gleam of our moon. Drift past the blue marbling of Earth, past the red haze of Mars, and come to rest in the realm of Jupiter, King of the gods, Lord of the planets. Here, in the cold reaches of the outer solar system, a gathering of moons encircles the giant-like courtiers attending a monarch. Galileo, peering through his primitive telescope on a frosty night in 1610, first glimpsed four of them, Io, Europa, Ganymede, and Callisto, bright dots tracing paths around their master. To him, these were not mere curiosities, they were evidence that our place in the universe was not as central as once believed. Even planets could have moons, and the heavens were richer than the philosophers had dreamed. Each of these Galilean moons has claimed a place in both scientific lore and the more shadowed halls of myth. Io, named for a lover of Zeus who was transformed into a cow to hide her from a jealous goddess, is itself a world of constant transformation. Its surface is riven with volcanoes, spouting plumes that reach far above its tenuous atmosphere, painting the landscape in sulphurous reds and yellows. In myth, Io wanders the earth, pursued by a gadfly, her agony mirrored in the restless, churning surface of her namesake moon. Europa, in contrast, is a world of quiet potential, a smooth, icy shell concealing an ocean deeper than any on earth. Europa's namesake was another lover of Zeus, swept away across the sea. In our time, Europa is the subject of dreams for astrobiologists and science fiction writers alike. What secrets might lie beneath that frozen crust? What alien creatures, what stories waiting to be told? In Arthur C. Clarke's 2010 Odyssey 2, the monolith makers warn humankind, all these worlds are yours except Europa. Attempt no landing there. The moon becomes a forbidden garden, an object of reverence and fear. Ganymede, largest of all the moons in the solar system, is named for the cupbearer of the gods. With its magnetic field and its sprawling grooved terrain, Ganymede is not merely a satellite but a miniature world, a planet in all but name. In Roman myth, Ganymede was carried to Olympus by Zeus's eagle, a story of ascension and transformation that seems apt for this lofty moon. Callisto, the most distant of the four, is a battered, ancient landscape, its face marked by the scars of eons. The myth of Callisto is a tale of tragedy and change, transformed into a bear, cast into the sky as a constellation forever circling in the heavens. The moon's cratered surface tells its own story, a record of ancient impacts and long, silent ages. The names of these moons are not chosen by accident. For centuries, astronomers have drawn upon the deep wells of myth and poetry, seeking to capture something of the mystery they felt upon first glimpsing these distant worlds. Even now, as we send robotic emissaries to orbit and photograph and probe, we cannot help but cloak these moons in legends. But the dance does not end with Jupiter. Saturn, adorned with its luminous rings, commands a court of more than 80 moons, each with its own peculiarities, each a jewel in the planetary crown. Titan stands out among them, a world cloaked in orange haze, its air thick with nitrogen and methane. For centuries, Titan was a point of speculation. A moon larger than Mercury, a world with a surface hidden from sight. Only with the arrival of the Cassini and Huygens missions did we glimpse its true nature, rivers and lakes of liquid methane, mountains of water ice, a landscape both familiar and utterly alien. Titan's name, drawn from the Titans of Greek myth, the primordial giants who ruled before the Olympians, evokes a sense of ancient power, of forces beyond human reckoning. In the imagination of science fiction, Titan becomes a stage for exploration, for survival, for dreams of future human settlement. Writers have imagined domed cities beneath its golden skies, methane seas plied by robotic submarines, and explorers gazing up at Saturn's rings from a frozen shore. Enceladus, another of Saturn's moons, is smaller and more elusive, but perhaps even more captivating. Beneath its icy crust, geysers spout plumes of water vapor into space, hinting at a warm ocean below. In myth, Enceladus was a giant buried beneath Mount Etna, his struggles causing the mountain to tremble and spew fire. On the moon, it is not fire but water that bursts forth, a sign of energy and possibility. The plumes of Enceladus, drifting like ghosts into the void, have ignited new hopes for life beyond Earth. Turn your gaze to the outer reaches of Neptune, and there you will find Triton, a moon that moves against the tide, orbiting its planet in retrograde, backwards against the flow. Its surface is marked by geysers that vent nitrogen ice, and its origins remain mysterious. Is Triton a captured wanderer, a world stolen from the Kuiper Belt? In stories, Triton was a sea god, son of Poseidon, who calmed the waves with the sound of a conch shell. The moon, Triton, with its icy geysers and frigid plains, is a place of calm and silence, a world where the music of the spheres is played out in the slow, stately movements of frozen gases. Even the smallest moons have found their way into our collective imagination. Phobos and Deimos, the two lumpy, potato-shaped moons of Mars, are named for fear and terror, the twin sons of Ares, god of war. Their names reflect the martial nature of their primary, but their presence in the night sky of Mars is gentle. Phobos rising and setting in a matter of hours, Deimos drifting slowly overhead. In the stories of science fiction, these moons become outposts, stepping stones for human explorers, way stations on the road to the stars. The moons of Uranus, in their cold, distant orbits, are named not for the gods of Olympus, but for the spirits and fairies of English literature. Oberon and Titania, Miranda and Ariel, Prospero and Umbriel, drawn from the plays of Shakespeare and the poems of Alexander Pope. It is as if, in reaching the farthest realms of the solar system, astronomers turn to the world of dreams and fancy for inspiration. These names evoke a sense of lightness, of magic, of the delicate interplay between scientific discovery and the flights of human fancy. Yet for all their poetic resonance, the moons are not mere symbols or backdrops. They are places of genuine scientific intrigue. They are laboratories for understanding the origins of our solar system, the processes that shape planetary bodies, the possibilities for life in the most unlikely of places, the icy shells of Europa and Enceladus, the methane lakes of Titan, the volcanic plains of Io. Each is a puzzle, a question, a whisper of things yet unknown. Across the centuries, The moons have inspired not only stories and myths, but also the dreams of exploration. In the pages of science fiction, they become settings for adventure and mystery. Robert Heinlein set his classic The Moon is a Harsh Mistress on a future lunar colony, where the struggle for independence mirrors the revolutions of history. In Kim Stanley Robinson's 2312, the moons of Jupiter and Saturn are transformed into habitats, their surfaces terraformed or tunneled, their interiors turned into gardens and sanctuaries. The moons become canvases for the imagination, places where the boundaries of the possible are stretched and redefined. And always the presence of the moons is accompanied by a sense of longing, of otherness, of the familiar made strange. Standing beneath the sky, whether on Earth or on some distant world, the sight of a moon kindles a connection to the cosmos, to the past, to the stories that make us human. There is a reason that the moon, with a capital M, has always haunted our dreams. It is both near and far, both known and unknowable. Its phases are a reminder of change, its presence a comfort in the darkness. So too with the other moons, their lights faint, their stories half heard across the great gulf of space. Each one is a beacon, a promise that the universe is larger than our imaginings, that there are always new dances to join, new partners to discover. Tonight, as you close your eyes and drift toward sleep, let your thoughts slip gently among the moons. Picture their slow revolutions, their silent, stately orbits. Hear the faint echoes of myth and song, the murmur of tides, the whisper of distant geysers. You are part of this cosmic waltz, a dancer in the great hall of the stars, your every breath a note in the universal music. The moons are waiting, patient as ever, their stories unfolding in the hush between worlds. And so, as the night deepens and the curtain of sleep draws close, the dance continues, moons circling planets, planets circling the sun, all swept along in a grand, unending ballet. The stories of the moons are far from finished. In the next turning, we may peer more closely at one of these companions, seeking the secrets written in ice and fire, in shadow and light, hidden just beneath the surface, waiting for a curious mind, a dreaming heart to listen. Under the velvet drape of night, as the sky yawns open to reveal its myriad lights, the moon has long held a singular presence in the human imagination. Its pale glow, cycling through phases with the patience of an ancient clock, has shaped myth, guided harvests, and inspired poets to lift their gaze. Yet the moon that hangs above our world is but one among a vast family of such companions, moons or natural satellites, each with their own secrets and stories, orbiting planets near and far. The faces of the night are many, scattered like pearls across the solar system, each distinct, each waiting to be unveiled. For centuries it was the custom to speak of the moon as though it were alone in the cosmos, a unique privilege of Earth, a silent sentinel meant exclusively for our world. This belief, like so many others, was quietly undone with the invention of the telescope. Galileo, peering through his lens in the early 17th century, became the first human to see the moons of Jupiter, 4 bright specks dancing in the planet's embrace. Their discovery marked the beginning of a slow, profound awakening, Our moon is not the solitary companion of a lonely planet, but one among hundreds, perhaps thousands, scattered across the heavens. Let us journey outward, leaving behind the familiar face of our own moon, marked with ancient seas of basalt, riddled with craters that speak of eons of cosmic bombardment, and visit those distant orbs whose mysteries are as rich and varied as the landscapes of our own world. First our gaze falls upon Io, the innermost of Jupiter's largest moons, a place so unlike our gentle lunar neighbour that it seems almost a fever dream. Io's surface is a patchwork of sulphur yellows, reds and whites, mottled with black scars. But it is not the colours that make Io remarkable. Beneath its crust, immense tides rise and fall, not from any ocean, but from the relentless pull of Jupiter's gravity. This tug-of-war, combined with the gravitational coaxing of neighbouring moons, kneads Io's insides like dough, generating heat by friction, a process called tidal heating. The result is extraordinary. Io is the most volcanically active body in the solar system. Its volcanoes do not merely simmer, they erupt with fountains of molten sulphur and silicate rock, spewing plumes hundreds of kilometers above the surface. On Earth, volcanoes are rare and mighty. On Io, they are commonplace and cataclysmic. The largest, Loki Patera, is a vast, bubbling lava lake, its shape constantly shifting, its brightness flickering as fresh magma wells up from below. Astronomers have watched as entire regions of Io's crust are resurfaced in the span of a few years, erasing craters almost as soon as they form. Here, the landscape is shaped not by the slow hand of geology, but by the ceaseless violence of volcanic renewal. The air on Io is thin, a mere wisp of sulfur dioxide gas, unable to shield the surface from Jupiter's intense radiation. It is a world both beautiful and deadly, a place where the ground churns and the sky is darkened by the breath of volcanoes. The existence of Io challenges us to rethink what a moon can be. It is not a cold, dead rock, but a fiercely alive world, its heart beating to the rhythm of a giant planet's tides. Drifting outward, we come to Europa, another of Jupiter's great moons, whose surface could not be more different from Io's inferno. Europa is encased in a shell of ice, bright as polished marble, scored by a delicate lattice of reddish cracks and streaks. This ice hides something truly wondrous. Beneath it, there lies a global ocean, twice the volume of all Earth's seas combined, kept liquid by the same tidal forces that torment Io, though here the energy is gentler, filtered through a shell of frozen water. Europa's surface is a landscape of paradoxes. There are few impact craters, suggesting that the ice is young, continuously repaved by slow movements from below. Vast plains are crossed by ridges and grooves, as though the moon's crust has been pulled and twisted by unseen hands. In some places, the surface is shattered into chaotic jumbles, slabs of ice rotated and tilted, refrozen after drifting atop the hidden ocean. Here and there, stains of reddish material hint at minerals, or perhaps organic compounds welling up from the depths. The possibility of life beneath Europa's crust is one of the most tantalizing questions of modern astronomy. On Earth, life thrives wherever there is liquid water, in the hot springs of Yellowstone, in the icy darkness beneath Antarctic glaciers, and around hydrothermal vents on the ocean floor. Could similar life flourish in Europa's ocean, warmed by the gentle heat of tidal flexing, nourished by chemical energy rather than sunlight? We do not yet know, but already Europa has become a beacon for our curiosity, a symbol of how little we truly understand the possibilities of the universe. The ice may be thick, perhaps tens of kilometers deep, yet somewhere below an ocean stirs in perpetual darkness, a world within a world waiting for the touch of sunlight or the probe of a distant visitor. Beyond Europa, the moon Ganymede orbits Jupiter, the largest moon in the solar system and the only one known to possess its own magnetic field. Ganymede is a true giant, larger than the planet Mercury, its terrain a tapestry of bright, grooved regions and darker, older plains. Its icy crust is thick, perhaps 100 kilometers or more, and beneath it, like Europa, there may be layers of liquid water or slush. Ganymede's magnetic field puzzles scientists. It hints at a salty, convecting ocean deep within, a place where water and rock may mingle and create the conditions for electricity to flow. Callisto, the fourth of Jupiter's great moons, is a relic of ancient times. Its surface is battered by craters, some overlapping in concentric rings like the ripples from a stone dropped into a pond. Callisto's crust has not been remade or resurfaced for billions of years. It is a time capsule preserving the record of the solar system's tumultuous youth. Yet even here, beneath the frozen silence, there may be an ocean insulated from the cold by layers of ice and rock. These four moons, Io, Europa, Ganymede and Callisto, are known as the Galilean moons, named for the man who first saw them through a telescope. They remind us that the night sky is richer and stranger than we can imagine, that even a single planet can be trailed by a retinue of worlds more diverse than any seen on Earth. But Jupiter is not unique in its collection of celestial companions. Saturn, too, is encircled by a host of moons, each with its own tale. Among them, Titan stands out, a world cloaked in orange haze, with rivers and lakes of liquid methane and ethane pooling on its surface. Titan's atmosphere is thick and rich in organic molecules, an alien chemistry that hints at what early Earth may have been like. When the Huygens probe descended through Titan's clouds in 2005, it revealed a landscape sculpted by rain and wind, where ice plays the role of rock and methane the role of water. Here, mountains of frozen water overlook valleys carved by flowing hydrocarbons, and the possibility of life is reimagined in terms of chemistry entirely foreign to our own. Enceladus, another of Saturn's moons, is smaller but equally compelling. Its surface is a gleaming shell of ice, crisscrossed by blue-tinted fractures known as tiger stripes. From these fissures, plumes of water vapor and ice crystals erupt into space, feeding Saturn's faint E-ring and offering a tantalizing glimpse into the ocean that lies beneath. The Cassini spacecraft, flying through these plumes, detected complex organic molecules and evidence of hydrothermal activity at the ocean's floor. In Enceladus, we see a world where the boundaries between moon and planet, between barren ice and the ingredients of life, are blurred. Farther still, Uranus and Neptune are attended by their own retinues of moons, less explored but no less fascinating. Miranda, a moon of Uranus, is a world of abrupt cliffs and canyons, its surface a mosaic of jumbled terrains that seem stitched together from mismatched parts. Triton, Neptune's largest moon, orbits in the opposite direction to Neptune's rotation, suggesting it was captured from the Kuiper belt. It is a place of frozen nitrogen, geysers of dust and gas, and a thin, hazy atmosphere, a testimony to the restless processes that shape even the most distant of the solar system's children. And beyond the orbit of Neptune, in the cold, dim reaches of the Kuiper belt, Pluto itself is accompanied by 5 known moons, the largest of which, Charon, is so massive compared to Pluto that the two bodies orbit a common center of gravity in space. Here, in the twilight of the solar system, we find that the distinction between planet and moon is not always clear. The dance of gravity can bind worlds together in ways that defy simple categories. Even Mars, our neighbor in the solar system, has its own modest moons, Phobos and Deimos, tiny, irregularly shaped bodies that may be captured asteroids. They are little more than shadows in the Martian sky, yet their presence reminds us that moons are everywhere, their forms shaped by capture, collision, and the slow accretion of dust and ice. If one were to imagine the solar system as a vast cosmic stage, the moons would be the supporting cast, each playing its own role, each contributing to the richness of the performance. Some are volcanic, others icy. Some are battered and ancient, others young and dynamic. They are not mere appendages to the planets, but worlds in their own right. Laboratories for geology, chemistry, and the possibility of life. And what of the limits of our understanding? For all that we have learned, the moons of the solar system are still shrouded in mystery. We have glimpsed their surfaces through the eyes of distant spacecraft, analyzed their atmospheres and plumes from afar, mapped their landscapes with radar and visible light. Yet for every question answered, a dozen more arise. How deep are the oceans beneath Europa and Enceladus? What powers the geysers of Triton? Do the strange chemistries of Titan and Pluto's moons give rise to forms of life utterly alien to our own? In the quiet hours of the night, as the light of our own moon drifts in through the window, it is tempting to think that the universe is well ordered, that we understand our place within it. Yet the moons remind us that the cosmos is a place of endless invention, of surprise and possibility. Our moon is not alone. It is one among a multitude, each as complex and storied as the planets they accompany. As we continue to look outward, to send probes and telescopes into the dark, the faces of the night reveal themselves one by one, each more wondrous than the last. The lessons they teach are not always simple or comforting, but they kindle that most precious of human qualities, curiosity. Somewhere in the distance, a volcano erupts silently on Io, painting the sky with sulphurous light. Beneath Europa's frozen crust, an ocean whispers in the darkness, holding secrets beyond imagination. Farther still, the haze of Titan hides lakes that mirror the orange glow of an alien sun. The faces of the night are not yet fully known. Their stories linger, waiting to be told as we drift onward, deeper into the mysteries of the solar system, guided by the gentle pull of wonder and the promise of discovery not yet fulfilled. Through the long corridors of human history, the urge to chase the shadows cast by distant moons has never truly faded. The night sky, so often serene and unchanging to the naked eye, conceals countless worlds, tiny spheres of ice and rock, companions to their planets, each holding secrets in their silent revolutions. In the beginning, our pursuit was limited to what the eye could discern. The moon's cratered face became a familiar friend to ancient astronomers and poets alike, but the other moons, those trailing Jupiter or Saturn in their distant orbits, remained nothing more than faint, wandering points of light. Still, the hunger to know more, what worlds might lie hidden in those wandering stars, persisted, quietly urging us toward invention. The story of our exploration truly began with a simple tube of glass and a few carefully ground lenses. In the early years of the 17th century, Galileo Galilei, a restless scholar from Pisa, raised his homemade telescope to the heavens. What he saw through that humble instrument was nothing short of a revelation. 4 bright points dancing in line beside the planet Jupiter, shifting subtly in position night after night. These were not stars, but moons, Io, Europa, Ganymede, and Callisto, circling their giant master. For the first time, humanity had evidence that not everything circled the earth. There were other centers of motion, other systems, other stories unfolding beyond our ken. Galileo's observations, chronicled in trembling ink on yellowed parchment, set in motion a revolution that would ripple through the centuries. The telescope itself, newborn and clumsy, was soon refined by others, Kepler, Huygens, Cassini, each generation building upon the last, sharpening lenses, lengthening tubes, peeling back the darkness with ever clearer vision. Through these glass eyes, astronomers glimpsed Saturn's strange rings, and the haze around Titan, saw the mottled face of Ganymede, and eventually the faint flicker of Enceladus's geysers. These were only hints, silhouettes moving behind veils, but they were enough to ignite the collective imagination. For centuries, our telescopic gaze remained earthbound. Observatories rose atop lonely mountains, where the thin air and still nights permitted clearer glimpses of the cosmos. Each improvement in optics, each new trick of capturing and focusing light, rendered the moons less mysterious, more detailed. By the 20th century, photography had joined the astronomer's arsenal, preserving fleeting moments of clarity, allowing careful study long after the night's observing was done. Yet even the finest lens could only hint at the true nature of these distant orbs. Were their surfaces solid or liquid, barren or blooming with life? Did their icy exteriors conceal oceans, or were they frozen through? The answers lay far beyond the reach of even the grandest ground-based glass. It was not until rockets began to roar skyward, breaking the bonds of gravity, that the era of true exploration dawned. First, we sent our gaze across the void with mechanical eyes, robotic spacecraft, crafted with precision and care, their bodies armored against radiation and the cold indifference of space. Each mission was a tentative step, each probe an emissary carrying our questions farther and farther from home. The early forays were cautious scouts, skimming past their targets in fleeting encounters. In 1973 and 1974, the twin Pioneer 10 and 11 spacecraft swept past Jupiter and Saturn. Their cameras, primitive by today's standards, caught glimpses of the swirling cloud tops and the pinprick light of attendant moons. Soon after came the grand tour of the Voyager probes, a pair of Voyagers in name and spirit, dispatched in 1977 to harvest secrets from the outer planets. Voyager 1 and 2, racing past Jupiter, Saturn, and beyond, sent back images that astonished and bewildered. Here was Io, its surface mottled with strange colours, yellows and reds, the marks of volcanic fury. Here was Europa, etched with a latticework of cracks, hinting at a hidden ocean below. Titan, Saturn's largest moon, appeared as a smudged orange orb, its mysteries concealed beneath thick clouds. For the first time, humanity saw the moons as worlds in their own right, each uniquely shaped by ancient collisions, internal fires, and the relentless sculpting of ice and wind. The Voyagers' discoveries posed as many questions as they answered. What drives Io's volcanoes? Could Europa's hidden ocean harbour life? And what lay beneath the golden haze of Titan? As technology advanced, so did our ambitions. No longer content with fleeting glimpses, scientists yearned for deeper, longer looks. Orbiters were conceived, spacecraft designed to loop endlessly around their targets, gathering data over months or years. Galileo, launched in 1989, became the first to orbit Jupiter, enduring the planet's punishing radiation to study its moons in detail. For 7 years, Galileo's instruments sniffed the tenuous atmospheres of Europa and Ganymede, measured the pull and tug of their gravity, mapped their icy crusts. It was Galileo that confirmed Europa's surface was indeed ice, fractured and mobile, and that beneath it a salty subsurface ocean might lurk. On Io, Galileo watched the plumes of volcanoes erupting into space, painting the surface with new sulphurous deposits. Saturn, too, became the object of sustained scrutiny. The Cassini mission, a collaboration between NASA, ESA and ASI, arrived at the ringed planet in 2004 after a 7-year journey. Cassini was a marvel of engineering, bristling with cameras, spectrometers, magnetometers and radar. Over the course of 13 years, it orbited Saturn again and again, sending its instruments to study the planet and its retinue of moons. Enceladus, previously thought unremarkable, stunned scientists when Cassini detected plumes of water vapor and ice particles spraying from fissures at its south pole. These geysers hinted at a subsurface sea, warmed by tidal forces, a potential cradle for life. But perhaps the most audacious chapter in our exploration of the moons unfolded on Titan, Saturn's largest and most enigmatic child. Shrouded in a thick, nitrogen-rich atmosphere, Titan had long resisted detailed study from afar. Its surface, cloaked in orange haze, was invisible to telescopes and even the powerful eyes of Cassini. To peel back the veil, a daring plan was hatched. The Huygens probe, built by the European Space Agency, would hitch a ride with Cassini and at the appointed hour plunge through Titan's clouds to land upon its alien terrain. On January 14, 2005, after a 7-year journey through the cold and darkness, Huygens entered Titan's atmosphere. For 2.5 hours it drifted downward, its parachutes unfurling in the dense air. Instruments sampled the composition of the clouds, measured winds, and snapped haunting images as the surface resolved below. Pebble-strewn plains, strange channels etched by liquid methane, the faint outline of distant hills, all were revealed in the muted golden light. When Huygens touched down, it became the first probe to land on a world in the outer solar system. For a brief, glorious hour, it transmitted data and images from Titan's surface, evidence of rivers and lakes, not of water, but of methane and ethane cycling in an alien weather system. Closer to home, the urge to touch and test extended to our nearest neighbors. Mars, with its 2 tiny moons, Phobos and Deimos, has been the object of fascination for generations. Their irregular shapes and cratered surfaces, so different from our own moon, raised questions about their origins and nature. Were they captured asteroids or remnants of a larger body shattered long ago? While the first spacecraft to visit Mars, such as Mariner 9 and the Viking orbiters, imaged its moons from afar, more recent plans have grown bolder. Several missions, including the ambitious Japanese MMX Martian Moons Exploration, are poised to send landers and rovers to Phobos, aiming to touch the surface, analyze the soil, and perhaps return samples to Earth. Each grain of dust, each pebble retrieved, is a time capsule from the solar system's early days, promising insight into the chaotic dance of planetary formation. The tools of our exploration have become ever more sophisticated. Modern spacecraft carry suites of scientific instruments, each tailored to a specific task. Cameras, of course, remain the eyes, capturing visible, infrared, and ultraviolet images. Spectrometers break light into its component colors. revealing the fingerprints of elements and molecules on a moon's surface or in its tenuous atmosphere. Magnetometers measure the invisible fields that pulse through space, while radar can peer beneath icy crusts to map hidden oceans or buried mountains. Onboard laboratories no larger than a suitcase heat, crush and analyze samples, searching for organic molecules, isotopes and the subtle signs of chemistry at work. Some missions have gone beyond mere observation, carrying the means to taste and touch. On Mars, rovers such as Spirit, Opportunity, Curiosity, and Perseverance have rolled across the red deserts, scraping the soil, drilling into rocks, and searching for clues to ancient habitability. While these have not yet visited the Martian moons, they presage a future in which robotic explorers will traverse the surfaces of Phobos and Deimos, their wheels crunching over regolith, untouched by any hand or foot. In the cold reaches beyond Mars, the dream of subsurface exploration beckons. Europa, with its tantalizing hints of a liquid ocean, is the target of NASA's forthcoming Europa Clipper mission, which will fly repeated close passes, mapping the surface in exquisite detail and probing for signs of life. One day, perhaps not far off, robotic landers will touch down on Europa's icy plains, drilling through the shell to sample the water below, a task of immense technical challenge, for the ice is kilometers thick and the ocean beneath is sealed in darkness. Enceladus, too, is a candidate for future landings. Its geysers, spraying water and organic compounds into space, offer a unique opportunity. Spacecraft can sample the plumes directly, analyzing their chemistry without ever landing, searching for the telltale signatures of life. The idea of sending a submarine to explore Enceladus's or Europa's oceans is no longer confined to science fiction, though the engineering required is staggering. Throughout all of this, the spectre of human exploration looms just over the horizon. The moon, our closest celestial companion, has already felt the pressure of human boots. Apollo's brief visits, decades ago, yielded treasures of rock and dust, but left much unexplored. Plans now gather momentum to return, this time to stay. Lunar bases, both robotic and crude, may serve as test beds for the technologies needed to venture farther still, to Mars, its moons, and eventually, perhaps, the icy satellites of Jupiter and Saturn. The challenges are immense: radiation, distance, cold, and the need for self-sufficiency. Yet each success, each new tool built, brings the prospect closer. As we stand on the threshold of these new adventures, the tools of exploration continue to evolve. Artificial intelligence guides spacecraft more precisely than ever before. Miniature drones and autonomous landers, small enough to fit in a suitcase, yet packed with sensors, promise to reach places once inaccessible. Swarms of tiny probes may someday descend into the canyons of Valles Marineris or the methane lakes of Titan, sending back data in a steady stream, a chorus of voices singing from the silence. And so the pursuit continues, from Galileo's trembling sketches to the pixel-perfect images of modern probes, from the first fuzzy glimpses to the planned landings on distant shores. Our quest to study the moons of the solar system is a testament to curiosity and ingenuity. With each new tool, each mission, we peel back another layer of shadow, revealing not only the nature of these worlds, but also the persistence of the human spirit. Yet even as our machines grow more capable, the mysteries multiply. Every answer raises new questions. Every discovery hints at deeper complexity. The shadows we chase recede, but they never quite vanish. There are still lakes to sound, geysers to sample, ancient surfaces to trace with gentle wheels. Out there in the cold and quiet reaches, the story of the moons continues to unfold, waiting for the next generation of dreamers, engineers, and scientists to listen, to ask, and to explore. In the hush that follows a probe's passing, in the stillness after a rover's wheel prints the first track upon virgin soil, something remains unresolved. The moons, ever patient, keep their counsel, guarding secrets older than memory, hinting at wonders yet unseen. As our gaze shifts from one world to the next, from the familiar to the unknown, a new chapter waits to be written in the great book of exploration, a chapter that will be shaped not only by the tools we build, but by the questions we dare to ask. What is it about a moon that calls out to the human spirit? Since time before memory, our ancestors have gazed upward, their fires flickering beneath the vastness, and seen that pale sentinel drifting through the night. The presence of a moon, be it the singular regal orb that lights our earthly darkness, or the many distant satellites circling other worlds, acts as a silent companion, a gentle witness to our fleeting lives. Yet the moon is not merely a backdrop to our existence. It is a mirror for our curiosity, a muse for our stories, and a keystone in our quest to comprehend the universe and our place within it. If you find yourself on a quiet night, the world settling into its hush, and you step outside to look up, the moon seems to hang there with a gentle indifference and a subtle intimacy. It is close enough for its features to be seen with the naked eye, its seas and craters, the scars of ancient impacts, the subtle shading that poets have likened to the face of a woman, a hare, or a man. Yet, for all its nearness, the moon remains unreachable to the unaided body, orbiting serenely above the tumult of the living world. Its constancy is both a comfort and a challenge. Its cycles mark the passing of time. Its tides pull at our oceans, and perhaps at the tides within ourselves. Through millennia, the moon has shaped our calendars and our myths. It has been the goddess and the god, the trickster and the guardian, the harbinger of madness and the keeper of secrets. Civilizations timed their plantings and harvests by its phases. The rhythms of life, menstrual cycles, migrations, even human sleep have danced to its silvery tune. In those ancient days, when the night was truly dark and the sky unspoiled by the glare of cities, the moon was a lantern and a clock, a symbol of the eternal return. Yet as our understanding deepened, so too did the moon's mystery. The invention of the telescope allowed Galileo to peer across the gulf and see that the moon's surface was not the perfect unblemished sphere that philosophers imagined, but a landscape of mountains and valleys, of light and shadow. This revelation reverberated through the human psyche. The heavens, it seemed, were not so different from the earth. The moon was made of dust and stone, subject to the same laws as our own world. The realization was both humbling and exhilarating. It diminished the divide between the terrestrial and the celestial, and in so doing made the universe feel both larger and more intimate. The moon's influence ripples through the tapestry of human thought. It is a motif in art and literature, a symbol of longing and lunacy, of transformation and reflection. Romantic poets found in its cold glow the perfect backdrop for melancholy and wonder. Its phases have inspired the cyclical motifs of religions and philosophies, waxing and waning, birth and death, loss and renewal. The moon's face, ever-changing yet eternal, is a reminder that all things are in motion, that nothing is truly static. But the moon is not unique in its power to move us. Across the solar system, other worlds possess their own moons, some small and irregular, others vast and enigmatic, each with its own story to tell. Jupiter's Galilean moons, Io, Europa, Ganymede, and Callisto, have become familiar names to those who watch the skies. Saturn's Titan, shrouded in orange haze, harbours lakes of liquid methane, and a landscape sculpted by alien rain. Even the battered little moons of Mars, Phobos and Deimos, inspire curiosity, their swift, restless orbits a reminder that not all moons are serene and gentle. The diversity of moons across the cosmos reflects the riotous creativity of nature. Some, like our own moon, are thought to have been born from violent collisions, great impacts that shattered and reassembled worlds, leaving behind a companion that would shape the evolution of its planet. Others are captured wanderers, asteroids ensnared by the gravitational embrace of a giant. Still others, like the icy moons of the outer solar system, are laboratories of possibility, worlds with oceans beneath their frozen crusts, where the conditions for life, perhaps strange and unrecognizable, might exist. To ponder these distant satellites is to confront the vastness of what we do not know. When we send our spacecraft to skim the surface of Europa or to linger in the shadowed canyons of Enceladus, we are reaching out not just with instruments and machinery but with imagination. In every pixel transmitted back, in every spectrum analyzed, we are searching for echoes of ourselves, or perhaps for something utterly alien. The moons of other planets are not merely objects to be catalogued. They are invitations to humility, to wonder, and to the endless expansion of our horizons. Yet for all the allure of these distant moons, it is our own that remains the most intimate. The Apollo missions, a fleeting dance upon the lunar regolith, marked a moment when the human imagination was made literal. For the first time, living beings who had evolved beneath the moon's gaze stood upon its surface and looked back at the blue marble of their birth. The footprints pressed into that fine, ancient dust are a testament to both our audacity and our fragility. The moon became not just a symbol or a mystery, but a place, a world with texture and history, with a story written in rock and crater. And still, the moon's role is not yet played out. As we contemplate the future of exploration, the moon beckons with silent patience. Its proximity makes it a proving ground for technologies and ambitions that may one day carry us farther from home. The lunar surface is a repository of the solar system's history, its rocks and soils holding clues to the formation of planets and the bombardment that shaped our world. Its dark craters, eternally shadowed, may harbor water ice, a vital resource for any who would linger there. The moon is both a destination and a stepping stone, a partner in our restless journey outward. But the moon's whispers reach deeper than mere utility. There is a philosophical resonance in our relationship with it, a reflection of the dance between the known and the unknown that defines the human condition. To look at the moon is to be reminded of our limitations and our aspirations, of the boundary between what can be touched and what can only be imagined. The moon is close enough to tantalize and far enough to elude. It is a symbol of what we yearn for and what we may yet achieve. Consider how the moon has shaped our understanding of time. Its cycles are woven into the very fabric of human culture. The lunation, the period from new moon to new moon, measures about 29.5 days, a rhythm that predates the invention of the written word. Many early calendars were lunar, their months beginning with the first slender crescent in the twilight sky. Religious festivals, agricultural rituals, and social customs have all been timed to the moon's phases. Even today, echoes of the moon's rhythm persist in our language and our lives. The word month itself is a relic of this ancient connection. There is a subtle irony here. As our technology has grown, as our clocks and satellites have rendered the moon's cycles less central to our daily existence, our fascination has not diminished. If anything, the moon has become more precious as a symbol of continuity in an age of restless change. It is a reminder that for all our progress, we remain creatures shaped by the cosmos, our destinies entwined with the movements of celestial bodies. The philosophical implications of moons extend beyond nostalgia. They provoke questions about the nature of companionship and isolation, of presence and absence. The moon is always there, even when it is hidden from view. Its gravitational pull binds us in a subtle embrace, its reflected light a balm for the darkness. Yet it is forever out of reach, a world apart. In this, the moon is a metaphor for all that we seek and cannot grasp, for the mysteries that lie just beyond the horizon of understanding. This sense of yearning is not unique to our species. If we imagine for a moment that there are other intelligences in the universe, beings who gaze up at their own skies, what do their moons mean to them? Do they too mark the passage of time by the dance of satellites? Do their poets and dreamers find solace in the glow of distant companions? Perhaps the presence of a moon is a universal invitation to reflection, a cosmic prompt toward wonder. In the centuries to come, our relationship with the moon may deepen and change. The notion of lunar settlements, once the stuff of speculative fiction, is now the subject of serious engineering and political debate. We contemplate outposts in the lunar night, habitats burrowed into the regolith, gardens nurtured beneath transparent domes. These visions are not merely technical challenges, they are acts of imagination, efforts to weave the moon more fully into the tapestry of human life. To settle the moon would be to forge a new chapter in our story, one in which the boundary between earth and sky is softened by the presence of human minds and hands upon another world. Yet even as we dream of footprints and habitats, there is a humility imposed by the moon's ancient silence. It has watched the rise and fall of continents, the dance of glaciers, the slow unfolding of life upon this blue sphere. Its surface bears the scars of time, a record written in impact and erosion, in the slow accumulation of dust. To study the moon is to peer backward into the history of our own planet, to read the autobiography of the solar system in the language of rock and shadow. And what of the moons beyond our solar system? As our telescopes grow ever more powerful, we begin to glimpse the possibility of exomoons, moons orbiting planets around distant stars. Each discovery expands the scope of what is possible, hinting at worlds rich with complexity and strangeness. Somewhere, perhaps, there is a moon orbiting a planet in a habitable zone, bathed in the light of a foreign sun. Perhaps its surface is etched with rivers and lakes, or its sky is painted with the glow of auroras. The existence of such moons invites us to imagine new forms of life, new stories waiting to be told. Our cosmic companions, near and far, remind us that we are not alone in the vastness. Whether as objects of study, sources of inspiration, or potential abodes for future generations, moons occupy a special place in the human imagination. They are the silent partners in our journey, witnesses to our questions and our quests. As the night deepens and the world grows quiet, the moon rises higher, casting its pale light across the land and sea. Its whispers are subtle, woven into the ebb and flow of tides, the cycles of growth, the patterns of dream. To listen is to remember that, for all our knowledge, mystery endures. The moon's presence is both a challenge and a gift, a reminder that the universe is vast, that our story is unfinished, and that the dance of earth and sky will continue long after our brief moment has passed. In the stillness between the stars and the earth, the moon hangs as a question and a promise, its face forever turned toward us, its secrets waiting to be unraveled. And so we watch and wonder and begin again. As our voyage among the moons of our solar system gently drifts to a close, their silvery orbits like comet tails fading into the hush of space, may your dreams wander softly through their quiet mysteries. Rest well beneath this cosmic canopy, and when you awaken, return for more Dreamtime tales to light your night with wonder.